Okay, today I'll be showing you how to draw cis trans isomers as well as enantiomers. Now, what are cis trans isomers? They can be drawn whenever, as long as you do not have the same groups on the same side of the carbon. So for example, if W and Z is not the same, or if X and Y is not the same, there will be cis trans isomers. Okay, so for example, if you draw it this way, this will be known as the cis molecule because the H or the Cl are on the same side. This will be known as the trans molecule. Okay, because they are on opposite sides. The same group is on opposite sides. Now, the moment, this will be trans, the moment you have something like this, let's say, the moment you have two groups here that are identical, there will not be any cis trans because no matter how you rotate, it will actually be identical. Okay. Now, if all four groups are different, there will also be cis trans isomerism. You are not required to identify whether it's cis or trans because it's actually something called EZ isomerism. Okay, but you must understand that it's part of cis trans isomerism. It can still exhibit cis trans isomerism, just that you will not be able to identify whether it's cis or trans. Okay, now let's look at enantiomerism. Enantiomerism occurs whenever there's a chiral center. So let me just show you what a chiral center means. Okay, so if you watch this very quick video, okay, so if you have object and you have the reflection, if they are identical, they are not chiral. Okay, so this example, these two objects are identical, so this is not a chiral object. Now, if you have a molecule where all four groups are the same, this is the reflection. You realize that you can superimpose them. So therefore, these two are identical once again. If you replace one of the atoms, okay, that one was identical as well. If you replace two of them, and this is the reflection, you can see that they are identical as well because you can superimpose them. They are identical. Now, what happens when three groups are different? When three groups are different, this is the reflection. You can still turn it in such a way where they can be identical. Okay, so these are still identical. Now, chirality only occurs when you have all four groups that are different. So if you look at it, this structure has four groups that are different. This is the reflection. No matter how you rotate or how you turn it, you cannot make them to be identical. They cannot be superimposed on each other. So if you look at this, the blue and yellow is aligned. Can you see the blue and yellow is aligned? But the red and purple are opposite sides. So they are non-superimposable. This is known as a chiral molecule. Now, how do we draw chiral molecules? Let me switch slides again. So for example, you have two bromobutane. Let me draw it out. Two bromobutane looks like this. You must first identify the chiral center. The chiral center is the one where all four groups are different. So this one over here is the chiral center. There are four different groups. 1, 2, 3, and 4. All four groups are different, so therefore this is the chiral center. How do we draw enantiomers? First, put the most complex group on top. Okay, next, this is very similar to a tetrahedral structure. Draw your bow and the dash. They can be randomly placed, it's up to you. Okay, so this part here is in the plane, so it's a straight line. The bow means it's coming out towards you. The dash means it's going into the plane away from you. Okay, then you draw the mirror image. The top remains unchanged. Okay, the top remains unchanged. This one shows the reflection. And this will be your CH3 coming out, and your H going in. So this is how you draw enantiomers. So this 1 minute of chemistry. See you the next time.